Hello everyone, I am Hammad from ECE Department first year SCA Engineering College, and today I am going to talk about water treatment and water technology. Water treatment and technology. When we hear the word water, the first thought that comes to our mind is that water is essential for all living things. About 71% of Earth's surface is covered with water, and water is categorized into underground water and surface water. Only rainwater is probably available in purest form, and the process of removal of all the impurities from the water and the hardness present in the water to make it fit for the domestic and industrial purpose is known as the water technology. There are two types of water, hard water and soft water. Hard water does not form lather with soap, whereas soft water forms lather with soap. When we take a bottle filled with water and add few drops of soap in it and shake it well, we observe bubbles formation in soft water and the water is clear. But in case of hard water, there is no bubbles formed and the water is very cloudy. This is due to the hardness of the water.
Hardness of water. In this module, you will learn about temporary and permanent hardness of water. If soap does not give good lather in water, the water is said to be hard. Now, what makes water hard? Well, calcium and magnesium ions present in water make it hard. Soaps contain sodium salts of higher fatty acids that serve to form lather. However, calcium and magnesium ions present in hard water react with these salts and form the corresponding calcium and magnesium salts. The resulting calcium and magnesium salts are not soluble in water. They remain on the surface of water as precipitates, commonly called scum, thus resulting in little lather. Calcium and magnesium ions in hard water are present as the soluble salts of calcium and magnesium, which may be their bicarbonates or chlorides or sulfates. When only bicarbonates of calcium and magnesium are present in water, the hardness of water is said to be temporary. Hardness of water caused by bicarbonates of calcium and magnesium is said to be temporary, as it can be easily removed by simply boiling the water. When temporary hard water is boiled strongly, calcium bicarbonate changes to calcium carbonate, water, and carbon dioxide. At the same time, magnesium bicarbonate changes to magnesium hydroxide and carbon dioxide. The resulting carbon dioxide escapes to the surroundings. On the other hand, the resulting salts, which are calcium carbonate and magnesium hydroxide, do not dissolve in water and thus form precipitates. The precipitates are removed by filtration, and this rids the water of calcium and magnesium ions. In other words, the water no longer remains hard. Another method to remove temporary hardness of water is Clark method. In Clark method, some amount of lime is added to hard water. Lime, which is chemically calcium hydroxide, reacts with calcium bicarbonate to form calcium carbonate and water. At the same time, lime also reacts with magnesium bicarbonate to form calcium carbonate, magnesium hydroxide and water. The resulting salts, calcium carbonate and magnesium hydroxide, as you already know, do not dissolve in water and thus form precipitates. And once the precipitates are removed by filtration, the water no longer remains hard. Once that we have studied about the temporary hardness of water, let us now learn about the permanent hardness of water. You may have noticed a hard white coating inside the electric kettles, on showers, and even inside utensils in which water is boiled. This hard white coating results due to permanent hardness of water. The permanent hardness of water is caused due to the presence of chloride or sulfate salts of calcium and magnesium. The white coating seen on different surfaces is nothing but a deposit of these salts. Permanent hardness cannot be removed by merely boiling the hard water. It can be removed by certain chemical methods that include treating the hard water with washing soda and Calgon's method, ion exchange method, and synthetic resins method. Let us first learn how permanent hardness of water is removed by treating the water with washing soda. When washing soda, which is chemically sodium carbonate, is added to hard water, it combines with the chloride salts of calcium and magnesium present in the water to form their corresponding carbonate salts along with sodium chloride. At the same time, washing soda also combines with the sulfate salts of calcium and magnesium to form their corresponding carbonate salts, but this time along with sodium sulfate. The carbonate salts of calcium and magnesium do not dissolve in water and thus form a precipitate. the precipitate is removed by filtration that frees the water of calcium and magnesium ions. And once these ions are removed, the water no longer remains hard. Calgon's method uses calgon, which is the commercial name for sodium hexametaphosphate, to remove permanent hardness of water. When calgon is added to water, each of its molecules ionizes to give 2 sodium ions and 1 complex anion. The complex anion further loses 2 sodium ions and captures 1 calcium ion or 1 magnesium ion from the water in return. As a result, the calcium or magnesium ion of the water becomes a part of the complex ion and no more remains free. This way, the complex anions of calgon capture all calcium and magnesium ions of the water, thereby removing its hardness. The ion exchange method uses zeolite, also called permutate, to remove permanent hardness of water. Chemically, zeolite is sodium aluminium silicate and it is insoluble in water. When zeolite is added to hard water, an ion exchange process occurs between the two. During the process, zeolite loses sodium ions to the water in exchange for calcium and magnesium ions. This way, the water becomes free of calcium and magnesium ions and is left with only sodium ions, which do not make water hard. In other words, the hardness of water is removed. The synthetic resins method uses ion exchange resins to remove hardness of water. Ion exchange resins are of various types, but the ones used to remove permanent hardness are represented as RNA. These resins are water insoluble and work by exchanging ions when added to hard water. Such resins exchange their sodium ions with the calcium and magnesium ions of the hard water, thereby freeing it from calcium and magnesium ions. This way, the water no longer remains hard.
Scale and sludge. When boiler is fed with hard water and heated to boil, steam is produced. As the water evaporates, the concentration of the dissolved salts increase beyond the saturation point. As a result, a hard and thick precipitate is formed on the inner walls of the boiler, and is called a scale. Sometimes, in the colder regions of the boiler, a loose slimy precipitate may be formed in the boiler feed water. This is called sludge. Caustic embrittlement. When the boiler is fed with water containing dissolved sodium carbonate and heated to boil, steam is produced. After the completion of the work, fire is extinguished. Hot water is drained off. But, when we observe the boiler wall, we can see tiny cavities. Into these cavities, hot water containing sodium carbonate clogs. Sodium carbonate converts to sodium hydroxide, and reacts with boiler material, forms Fe3O4. Sodium carbonate reacts with hot water to form sodium hydroxide. So produced sodium hydroxide reacts with boiler material to form sodium ferrite. Further, sodium ferrite reacts with water to form sodium hydroxide and ferrosulfuric oxide. It can be observed from the above reactions that sodium hydroxide is regenerated and further attacks the boiler material. As time proceeds, the majority of the boiler material is attacked, converts to ferrosulfuric oxide and thus becomes brittle. This phenomenon is called caustic embrittlement. Caustic embrittlement can be prevented by use of soft water, use of sodium phosphate in the external treatment, instead of sodium carbonate, addition of compounds like sodium sulfite, tannin, and lignin, prevents the caustic embrittlement, due to blocking of the cracks, thereby preventing the infiltration of alkali.
Thanks for watching.